All right, today we're going to look at exponential growth and decay applications. We have our exponential growth formula here, A equals P, 1 plus R to the T. P is going to be the principal, which is the initial amount. B, the base, is 1 plus R, where R is equal to the interest rate. If we're doing exponential decay, the only difference with exponential decay is that we're subtracting instead of adding. Just to revamp some graphs, this graph on the left would be exponential growth. This graph on the right would be exponential decay because it is decreasing. All right, first example, Mr. Foster started a new job. His salary for the first year is $30,000. That's going to be our initial amount or our principal. He receives a 5% raise. That's going to be our interest rate. Write a formula to define Mr. Foster's salary for the nth year. So Y equals, he starts with $30,000, 1 plus 5% raised to the T. We can type the 1 plus 5% in the calculator. I'll show you how to do that on Desmos right quick. If we type the 1 plus 5% in Desmos, it's going to look something like this. There's a percent button over here. It's going to say percent of what? We always have to type a 1 there. Otherwise, it's not going to work. That's 1.05. So we get 30,000 times 1.05 raised to the T. And now we can use that equation to do basically whatever we want with Mr. Foster's salary. We can predict his salary after 7 years. So T is going to equal 7, 1.05 raised to the 7th power. And we can type that in the calculator exactly like it looks. So back in Desmos, we can do 30,000 times 1.05. We're going to hit that exponent button right here, and we're going to put 7. So after 7 years, Mr. Foster will be making $42,213.01. $42,213.01. We can also figure out how long it's going to take Mr. Foster to reach a certain pay, in this case, $50,000. So we want to know how long it's going to take Mr. Foster to have $50,000. That's going to be our Y value. And that's going to be equal to our equation. 50,000 equals 30,000 times 1.05. But we do not know T this time. We can solve this equation by rewriting it as a logarithm. So we're going to divide by 30,000 on both sides. 50,000 divided by 30,000, we just cancel out the zeros, or type in a calculator. We get 5 over 3 equals 1.05 raised to the T. We can rewrite this as a log at this point, a logarithm. The base is going to be 1.05. The 5 over 3 and the T are going to switch places. So the 5 over 3 is up inside the parentheses, and that is equal to T. We can type this in the calculator. We can hit the fraction button first. We can hit the fraction button first, and then we're going to go to the function feature. We're going to type in log, and on top we want log of 5 over 3. So we can do 5 over 3. Oh, whoops. If we can put that in the right spot, the 5 over 3 goes inside the parentheses. And then on the bottom we get log again of the 1.05 this time. And that's going to be about 10.46 years. So T equals 10.47, we round. So if he worked there for 10 years, he actually wouldn't make $50,000 because he's not going to get a raise high enough once he's worked there for at least 10 years. He's not going to get a raise in the middle of the year. So he's going to have to work there for at least 11 years to get a raise. All right, we're going to do one more of these. We're not going to do the last 2 today. Janet purchased a new car for $25,000. That's going to be our initial amount. The moment she drove the car off, it began depreciating. That lets me know that this is exponential decay, and our rate is 15%. So we want to write a formula. So Y equals 25,000 times 1 minus 15% raised to the T. We can type the 1 minus 15% in the calculator. If we will, we can do that on Desmos. 1 minus 15% of 1, that's 0.85. So we get 25,000 times 0.85 raised to the t. This 0.85 number, we do not want to round that at all. Even if our calculator gives us like 4, 5, 6, 7, 8 decimal places, we really don't want to round those. How much is Janet's car worth after 4 years? So we know the t value this time, so we get 25,000, 0.85 raised to the t, but we do know that t is 4, so raised to the 4th power. We can type that in the calculator. 25,000 parentheses 0.85. We're going to hit the exponent button. We're going to put 4 there. So after 4 years, this person's car is only worth $13,050.16. $13,050.16. How many years would it take Janet's car to depreciate to half of its current value? So we can do 25,000 divided by 2 in the calculator. That is 12,500. And that's going to be the y value this time. So 12,500 is equal to 25,000 times 0.85 raised to the t. We're going to divide both sides by 25,000. You can type the 12,500 divided by 25,000 in the calculator. That is 1/2. And 1/2 equals 0.85 raised to the t. We can now rewrite this as a log. The base is going to be 0.85. The 1/2 is going to end up inside the parentheses, and that's equal to t, because with a logarithm, the input, which is t, and the output, which is 1/2, are actually going to switch. And then we can type that in the calculator. We're going to hit the fraction button first. We're going to type log of 1/2 on top. So we get log of 1/2 on top. And then we get log of the base on the bottom. The base was 0.85. So log of 0.85 in the denominator. It's going to take about 4.26, 4.27, 4.3 years for this car to reach half of its current value. And that is exponential growth in decay word problems. The other two on the notes are very similar to the ones we just did. We would solve them the same way. We would set everything up the same way.